Hello, this question is about particle motion in fluids. The question is, starting with the force balance on a single particle at terminal velocity, show that CD is equal to this expression, where CD is the drag coefficient, G gravity, acceleration, D particle size, VT terminal velocity, rho S the particle density, and rho F the fluid density. Okay, so the definition of the CD, the drag coefficient, is equal to FD, the drag force, divided by 1 divided by 2 rho F Vt square times A. Okay, and if you consider the particle in the fluid, so you have downward gravity, downward gravitational forces, upward buoyancy forces, and upward drag forces. And if you write the force balance here, at the equilibrium sigma F should be equal to 0. Therefore, 0 will be equal to downward gravity minus upward buoyancy forces minus upward drag forces. Therefore, 0 will be equal to Fg. The downward gravitational forces will be mg, and m is rho s times the volume, that is pi d with the power of 3 divided by 6, times g minus buoyancy forces, that is the weight of the displaced fluid, which will be rho f, times volume of the displaced fluid, which is equal to the volume of the particle, that is pi d3 divided by 6 times g minus ft. Instead of ft, I write this multiplied by CD, which will be equal to 1 divided by 2 rho F Vt with the power of 2. Instead of A, I write pi d2 divided by 4, that is the projection of the particle on the horizontal plane, times CD. Okay? And so this is the expression here. The pi will be cancelled out, d2 will go out here, there will be 1d here and 1d here. If you factor dg divided by 6, gd divided by 6, here you will have 1 rho s, here you will have rho f, and then this one I bring to the other side of the equation. 2 times 4 will be 8, 1 divided by 8 times rho f times vt with the power of 2 times cd, and therefore cd will be equal to this term divided by this term, which will be equal to 4 divided by 3 gd divided by vt with the power of 2 times rho s minus rho f divided by rho f. And that is the solution to this question.